Welcome to the first video of the series called Trial Preparation in Mathematics. In this series, we are going to prepare for the trial exams that are upcoming. So let's jump straight to it. And question 1 says, given x plus 3 multiplied by 3x minus 1 equal to m, solve for x if m equal to 0. Questions like these, we know that we don't have to sweat a lot because there are only 2 mark questions. They shouldn't bother us that much. So in other words, what we are given is we have x plus 3x minus 1, apologies for the insane handwriting, 3x minus 1 equal to 0. So we know that if 2 factors are multiplying like this and they are all equal to 0, it means one of them should be equal to 0. We can say that x plus 3 equal to 0 or 3x minus 1 equal to 0. And then we'll find that x is either equal to -3 or x is equal to a third. Like that, and we're done. You don't want to waste too much time on questions like these because you need your time for more complex questions and more strenuous questions. Right, so now let's go to 1.2. And then 1.1.2 says, solve for x rounded to 2 decimal places if m is equal to 6. The keywords or the key phrase that you should be looking for, or that should give you an idea what you should be doing, is rounded to 2 decimal places. That means we are going to use the quadratic formula. And then we're going to say x plus 3, now m equals 6. In this case, we can no longer say x plus 3 equals 6, 3x minus 1 equals 6, because this is no longer 0, right? So in other words, we have to multiply in x multiply that, and multiplies that as well, and 3 multiplies this, and it multiplies that as well. So we are going to have 3x squared minus x plus 9x minus 3. We take this 6 to the left hand side and it's going to be -6 being equal to 0. Because it's a 5 mark question and they give you a clue to round off 2 decimal places, what we're going to do is we're first going to say 3x squared plus 8x minus 9 equal to 0. So we're going to say x will be equal to minus b plus minus the root of b squared 4ac all divided by 2a. So what is our b? Our b is positive 8. So in other words, we're going to have positive 8 inside, plus minus 8 squared minus 4, 3, -9 over 2, 3. I'm going to put this in the calculator real quick and we're going to find the answer, the x values. Try to do this in your calculator and see if you get the same answers as I do. So I found the x values to be 0.85 and -3.52. If this is incorrect, please write down the correct answers down in the comments below. It's possible that I might have punched my calculator incorrectly, but this is what I found. Right, 0.85 and -3.52. Now let's move on to the next question. Let me erase this real quick. Question 1.1.3 says, the turning point of f of x equal to x plus 3, 3x minus 1 is -1 and a third and -8 and a third. They say, how must the graph of f be translated for it to have equal roots? Now let's try to look at this in a different eye. So we have our f of x being equal to x plus 3, 3x minus 1 with turning point values of -1 and a third and -8 and a third, right? So if you don't like to use mixed fractions like this, you can convert this into an improper fraction like -4/3 and -25/3. It's still the same thing. It's just that I don't like working with mixed fractions. They look ugly to me. You can do this if you want, but I'm going to work with both. So in other words, we have f of x being that and we have turning points being either this or that. How must the graph of f be translated for it to have equal roots? Now let's look at this. We know that this is going to have positive a because when we multiply x and x, we're going to get 3x squared. So we don't need to go further and get B and C. We just need to look for A so that we can know the shape of the graph, right? So we know that the shape of the graph, due to that A has to be smiley because A is positive. Because the turning points are all negatives, we can extrapolate and say we have something like this. So they are all negative. It means X has to be negative and Y has to be negative. We can come and say, let's plot this and say our turning point is -4/3 and -25/3. Don't forget that I just converted these to the improper fractions. So we have -4/3 and -25/3 right there. We are told that how must the graph of f be translated for it to have equal roots, right? So in order for a graph to have equal roots, because here it has two roots that are not equal. Look at this. We have this root right here and we also have this root right here. This x value is not equal to this x value, right? We can agree on that because it's not the same point. So in order for a function to have two equal roots, it needs to be directly on top of the x-axis like this, right? So it needs to be directly on top so that it can have the upcoming x-intercept and the outgoing x-intercept. So that's double because it comes and goes. It may seem as one root, but it's not necessarily one root. It's this root twice because it comes and it leaves from that very same root. So we have one root in our eyes, but the function knows that it's two roots that are just equal. So it's an equal root. So to have an equal root right there, we need to drive this function up until it reaches this point right there. Apologies for the drawing, right? So we need to drive f until it gets to that point. So if the y value of the turning point is -25/3 or -8 1/3, we need to move it up by the value of the turning point because this is the minimum value that it has. So if we can move it up by that value, that minimum value, and cancel out this to be 0 because we need it to be just at the x-intercept. So we need it to be at -4/3 and 0, right? So in other words, the answer to A should be we need to shift f or f of x by 8 1/3 units up, or we need to shift f by 25 1/3 units up, right? Because we just discovered that we need to take this f up by the y value that we have. So we have -25/3. To cancel out -25/3 so that it becomes 0, we need to add a positive 25/3, which is the same as 8 1/3 or 8 1/3, right? Now let's go to B. B says, hence, when they say hence, it means you don't need to think further. You need to use whatever you've been given right here, right? Or whatever you've found right here. So hence, write down the values of k for which f of x plus k equals 0 will have no real solutions. Again, let's look at this. Let me try to erase this graph and make it make sense again because it's a little bit crappy. We have the turning point, which was -4/3 and -25/3. And this graph was shifted upwards by 8 1/3 or by 25/3 units up. Right, so B says, hence write down the values of k for which f of x plus k equal to 0 will have no real solutions. What does it mean graphically to have no real solutions? You remember when I said the roots of these are not equal, but they exist. We have root 1 and we also have root 2. So that's root 1, root 2. And then when we shifted this graph up, we saw that we now have only one root because it's just one. But intuitively, we might think it's only one root, but the graph or the function knows that it's not one root because it's one root coming in and one root coming out. So it has to be two roots. It's just that the roots are equal. So we can just say intuitively we have one root, right? But look at this. when we take the graph upwards, let's say like this, and it doesn't touch anything, if the graph was to be taken upwards further, there would be no roots at all, right? Because here we had two unequal roots, and here we had just one, which means we had two equal roots. And then the more we take the graph up, we see that it no longer has any roots. So that's what we mean to have no real solutions. It means if we're going to solve for this graph, it's not going to give us any solution. It's going to give us math errors because it does not touch the x-axis. This one has two unequal roots, and this one had one root intuitively, but we know it's two roots. They are just equal. And the third one has no real solutions or no real roots, right? So to solve for k in this case, we can intuitively see that the more we take this function up further, this function will no longer have roots. We got that if we take this function up by 8 1/3 units, we found that we can place this function directly at the x-intercept. But what we notice now is the more we take it up more than 8 1/3, we are going to have no real solutions. So in other words, the more we take it up, it's going to have no solutions because we've already lifted it up by 8 1/3 units. I hope this makes sense. If it doesn't make sense, please, you can leave a comment down below and I'll try to explain it a little bit further. Let's move on to question 1.2. Question 1.2 says, solve for x and y simultaneously in the following equations. So to solve for x and y simultaneously, we can use three methods. We can use elimination, we can also use substitution, and the other one that a lot of people don't know is we can use a graphic way to solve for x and y. In other words, you can plot the first equation and we can plot the second equation and see where the two graphs meet, and then we can find x and y. But in an exam like this, you don't want to waste too much time drawing graphs. So we are going to stick with substitution because elimination is going to get a little bit tricky here because we have x squared and xy. So let's try to use substitution because intuitively I find it to be a little bit easier. We have x minus 2y being equal to 3. I want us to rewrite this and take this negative 2y to the other side. So we're going to say x being equal to 3 plus 2y, and this will become our first equation, right? So we have 4x squared minus 5xy being equal to 3 minus 6y, and this should be our equation 2, right? I want us to which is to substitute equation 1 into equation 2. Where there is x, we're going to put 3 plus 2y. So in other words, 4, there was x squared. So in other words, we're going to say 3 plus 2y squared minus 5. There is x right there. So we're going to also put 3 plus 2y. And then we have y, which is being equal to 3 minus 6y. So we now only have y's right there, so it's easy to solve for an equation if it only has one variable, right? So what I'm going to do is I'm going to quickly multiply out these, so you can try to multiply yourself as I quickly multiply. So you can pause the video and try to multiply and see if we come up with the same answer. I'm going to quickly do this, so stay tuned. After that montage of multiplying out, I found that these are the answers. Again, if you think these are incorrect in any way, please feel free to say it in the comments because it's possible to punch incorrectly somehow or to think to multiply incorrectly. Now let's try to bring everything on the same side. So in other words, we're going to bring 3 and negative 6y to the left hand side, and I would like us to format this in a way that we know. So in other words, we're going to say 16y squared minus 10y squared because these are the y squareds, and then I would like us to say 48y minus 15y plus 6y, because this is the 6y that is coming from the right hand side, right? So let's see, 48, 16, negative 15, negative 10y squared, right? I think we're done with that. So let's come and say 36, and then we say negative 3 equal to 0, right? So this is in a way that we are used to. 16 minus 10, that's going to be 6y squared, and this is 48 minus 15 plus 6, which is going to give us 39. And then 36 minus 3, so that's just going to be 33. If you want, you can simplify this and divide everything by 3, but it's unnecessary. We just need to solve this by using the quadratic equation. So this is your A, this is your B, and this is your C. So you don't need to write down the quadratic equation here. In the exam, though, you don't need to write down the quadratic equation because it's not necessary. But we are going to say y will be equal to minus b plus minus the root of b squared minus 4ac all over 2a, like this. So you can do this on your calculator without actually writing it down like this. Here I'm just doing it so that you understand what I did. So I'm going to place my b. My b is positive 39. So in this case we have negative into 39 plus minus the root of 39 squared minus 4, 6, because that's my A, and then 33, which is my C. I hope this does not give us math error because I think this is too big, but 39 squared is also huge. So let's see how it turns out. So we have 2 and then it's right there. So I'm going to punch this on my calculator so you can do the same as well. I found my y's to be negative 1 or negative 11 over 2 right there. So if these are incorrect, shout out in the comment section. If we know that y is negative 1 or negative 11 over 2, we know that we said x was equal to, let's see, equation 1, we said x should be equal to 3 plus 2y. So we can have two answers as well because we have two y answers. So we're going to say x is equal to 3 plus 2y being negative 1, or x equal to 3 plus 2y being equal to negative 11 over 2 right there. So here we're going to have 3 minus 2, which is the same as 1, or x equal to 3. 2 and 2 will cancel out because they're multiplying. This is the same as 2 over 1 multiplied by negative 11 over 2. So 2 and 2 cancel out. So we'll only be left with negative 11. So this is the same as 3 minus 11 is what? Is negative 8. Right? So we have 1 and negative 8 right there. Question 1.3. We are told to solve for x if we have those two factors multiplying and are giving us 0. So here's what we do. We know that from the first question where m was 0, we can also do the same thing. We can say 3 to the power of x minus 1, 3 to the power of x minus 12 being equal to 0. So if the multiplication of these two gives us 0, it means this should be 0 or this should be 0. So we can easily say that 3 to the power of x minus 1 should be equal to 0, or 3 to the power of x minus 12 should be equal to 0, right? So we are trying to solve for x. In this case, let's first deal with 3 to the power of x, and then we take negative 1 to the other side. So this is going to be the same as 3 to the power of x being equal to 1. So to solve for x in this case, we can rewrite 1 and say 3 to the power of x being equal to 3 to the power of 0, because 3 to the power of 0 or anything to the power of 0 should be 1, right? We have equal bases. In other words, x should be 0 in this case, right? So now let's come and solve these other ones. We can also take 12 to the other side and say 3 to the power of x is equal to 12, but you cannot write 12 by rewriting it into a prime base of 3, because the factors of 12 are actually 1, 2, 4, 3, I forgot 3, 6 and itself, right? So these are the factors, and we cannot say it's 3 squared or 3 to the power of 3. So in other words, we need to find a way to solve this one without using prime basis. And it turns out in grade 12, you were taught logarithms. You can solve for this using logarithms because we cannot rewrite it and say 3 to the power of something in this case. To use logarithms, I have a very simple way of solving for something. So what I do is I take what I am supposed to solve for. In other words, I take x right there and then I write my log right there, right? And then look for what was the base before. So the base was 3, right? And the index was x in this case. So the base was 3 and the index was x. So if 3 was the base, it means it has to be the base again. And then here you just come and write the 12. Did you see what I did? So I took the index or the exponent because I am looking for it. So if I am solving for x like this, I take the exponent and then I just write it like this, just independently, right? So and then I ask myself, which one was the base between 3 and x? If 3 was the base, it means it has to be the base of the log again, because this is log 12 base 3, so it's log 12 base 3, right? So you're going to punch this in your calculator and we're going to get 2,26. So we have our x being equal to 0 or our x being equal to 2,26, and we're done with that. Right, question 1.4 says, so for n, if negative n squared plus 14n plus 15 is greater than or equal to 0. So this is a classic inequality. In other words, we have negative n squared plus 14n plus 15 greater than or equal to 0. So I do not like to work with negatives in front of n squared or in front of anything squared. So what I'm going to do is I'm going to divide everything by -1. So in other words, we're going to have this divided by -1, this divided by -1, and this divided by -1, and this as well divided by -1. So we're going to have n squared minus 14n minus 15. The sign changes because we're dividing everything by a negative. So this will be less than or equal to 0. So in everything that we're going to do now, we no longer look at this, right? We now look at this new inequality because we've revolutionized the old inequality per se. We now look at n squared minus 14n minus 15 because it's easier to look at. We know that this is just a smiley graph this side, right? So we are solving for n. To solve for n in this case, we need to find the critical values. What are our critical values in this case? So in other words, we are looking for factors of 15 that when we multiply should give us -15, and when we add should give us -14. So the factors of 15 are 1, 3, 5, and 15, right? So we're looking for two factors or two numbers that when we multiply should give us -15, and when we add or subtract should give us -14, like that. By the looks of it, we have 15 and 1 because 14 can only come from 15 and 1. So in other words, if we try -15 multiplied by 1, -15 multiplied by 1 is -15, but -15 plus 1 is -14. So here we can come and say this is the same as n minus 15 and plus 1, because -15 plus 1 gives us -14 is less than or equal to 0. So this means that our critical values are 15 and -1. You are not supposed to write any equal sign here. Some people might say n is equal to 15 or n is equal to -1. No, we are not supposed to see any equal sign in this case because this is an inequality. So to solve for n now, we can use two methods. The one that I like and the one that I don't like the most. The first one that I like is using a graph, because we know that this is a parabolic graph, so we can just sketch it. We don't need to be too precise with it. We know that we have this line right there, this function is actually a smiley parabolic, because I said we look at this one now. We now look at this one. We no longer look at the old one. It means the parabola is smiley, so we can come and sketch this and say, oh, it's like this. Our critical values are -1, because negative is on the left, and then 15 is on the right because it's positive. So in this new inequality that we just revolutionized, we are looking for where the function is less than or equal to 0. So this is 0, and the function becomes positive the more it goes up the y-axis, and the function becomes negative the more it goes down the y-axis, right? So we are looking for where the function is negative. So the function is negative below the x-axis like this, because y is negative. Y is the function. Remember that. So we have this being the region where this function is negative or equal to 0. So in other words, our answer should lie between -1 and 15, because we can see that the region is between -1 and 15. So n should be between -1 and 15. But we are also told that it should be equal to 0 again, right? So we can come and say, oh, we have these two right there. So n should be greater than or equal to -1, but less than or equal to 15 in this case. So this is the answer. So the graphical way, you don't need to use a calculator. You just need to use your eyes to see where the graph is negative or where the graph is positive, like that. No need to use any calculators. But you can use the second method, which is using the number line system. Let me erase this. So using the number line system, we're going to plot our critical values like this, and we're going to have -1 right here, and we're going to have 15 here. So we look at the inequality sign and see if it has any equal. So we're going to have these 2 points being shaded because there's an equal to right there, and then we have this right there. So here's what we have. We are going to look for a number that is less than -1 in this case, and then see if the number is negative or positive, because here we're looking for when it is negative. You see, because it's less than or equal to 0. So we're looking for either being equal to 0 or negative. If it's negative, it means that it will be the answer, but if it's positive, then we'll discard it. So let's take any number that is below -1, like -2, and place it in our inequality. So we're going to say -2. So after substituting -2, I found that you get -17 on this vector, and here you get -1. It means our answer will be positive 17. So in other words, here we're going to get a positive answer. So intuitively, we don't need to calculate the other ones, because if this one is positive on the far end, also on this far end, it's going to be positive, which means the middle can either be positive or negative. So we just need to find if the middle is positive or negative. So we're going to try and look for a vector that is greater than -1, like let's say 0. So we're going to say 0 here, -15, and 0 plus 1. Here we're going to get -15 times 1. The answer is -15, and the answer is negative. So it means the answer is negative. So they are looking for where the answer is negative. So it means the answer should be between -1 and 15. And because points are shaded, it means our answer is -1 less than or equal to n less than or equal to 15. So the answers are still the same, whether you're using the graph or whether you're using this number line system. Right, so we've come to the end of question 1, and in the next video I'll be continuing with question 2. So take a little break and go through what we did and see if you understand. If you don't understand, leave a comment in the comment section. Be sure to be back for question 2, which is up next. So see you in the next video.